Hey class, this is Mr. Roberts at Shasta High School, room 309, and we're going to start a chapter 4 homework assignment. I think it's question 17 through 22. So let's take a look at our first question. This first question gives me models for two different neighborhoods. So I guess someone went out and they built a model that predicts the price of a house given the number of square feet. So the price of a home in thousands of dollars is associated with the number of square feet in the home. Makes sense, right? The bigger the house is, the more square feet it has, the more likely it is that it'll cost more. Home prices in Smallville. Okay, so this is the first time we've seen this. There's like two different communities. Home prices in Smallville can be modeled by this equation. The price is 150 plus 0.041a, where P is the price of the home in thousands of dollars. Okay, so remember, it's going to spit out a number. We have to tack on three numbers at the end. So the number we get from this equation, we have to put 3 zeros on to know what it is, and because it's thousands of dollars. And A is the square footage of the house. The other community is called Fancyville. Oh, everyone wants to live in Fancyville. Fancyville, their equations, their homes can be modeled using this equation. So a person, knock, saw a real estate advertisement for a house that had 280 square feet. Okay, so this is giving me a value of A. So A for this house in question was 280 square feet. No, 2,800 square feet. I'll just say Quare feet. And it's selling for $280,000. So that's its price. And which city should she predict the home is in? Okay, so it's possible it could be one of these two communities. Which one makes the most sense? So let's go back down and write down the equations of these houses, right? So communities. So Smallville, the price was 150 plus 0.041a, and we know what a is. And the other community, Fancyville, the price is modeled by 250 plus 0.1, nope, not 9, 0.198. So what I'm going to do is literally just plug that value of A into both of those equations. So let me grab the calculator here. And I'm going to go ahead and take the fact that the square footage is 2,800 square feet, and I'm going to store that in X. And now I'm going to go ahead and run through both equations. So I've got 150 times 0.041x. I get a number for this town. 150 plus 0.041x. Okay, and then let's do the same thing for the other neighborhood. So I'm going to go 250. Oh, I've made a mistake. This is supposed to be, oops, that's a big mistake. This is supposed to be addition. Let me change. Let me clear this line. Let me just type this one. Let me clear this line. Clear you, and that's good, I guess. Okay. That was embarrassing because what I did was instead of 150 plus 0.041x, I did multiplication there. So when I do that, I get 264, and then these are 1,000. So this would be 264. So this price would be $264,800, right? That's what the model predicts the house would cost in Smallville. And then in Fancyville, the model was 250. So I got the 250, and I'm going to add, yeah, life lesson, 0.198x. And when I do that, I get, ooh, it's a lot. I get 804 and 4,000. So $804,400. So based on the advertisement and the fact that the advertisement said that the house was listed for 280,000, I would say that this house is probably in Smallville, right? Now, it's possible that it could be in the other community. This is no guarantee, but my sense is that the house would be more expensive, perhaps. I mean, it could be just it's a mess and it needs a ton of work. I don't know. But the house probably is in Smallville. Let's move on. Next question, number 18. It says a team of students is trying to answer the scientific notation problem a number times another number. Okay. George thinks they should use an area model because there are two terms multiplied by two terms. Cadell thinks the answer is 8 times 10 to the 10th, but cannot explain why. Lawrence thinks they should multiply the like parts. Her answer is 8 times 100. Oh my gosh, to the 21st. Who is correct? Explain why each student is correct or incorrect. So I guess in terms of Cadell, this is just one term, right? There's no addition anywhere. So I just have a 2 times 10 to the third times a 4 times 10 to the 7th. So this, no, that's George that thought that, right? There are not two terms. It's just one term. So this problem does not have multiple terms. In terms of the next one, Cadell thinks it's this, but he can't explain why. Lauren thinks they should just multiply the like parts. So she did the 2 times 4 got 8. And then she did 10 times 10 is 100. Okay, so here's what I would say. Lauren, when I look at this problem, this is literally what this is. It's 2, and then it's times 10, 10, 10. And then it's times a 4 times 1, 2, 3, 4, 5, 6, 7. I like exponential notation. I like that I don't have to write that. So when I look at this, everything's being multiplied. And I can use the commutative property and pull out the 2 and 4 and multiply those. So 2 times 4 is 8. And then in terms of what everything else is, it's a bunch of 10s, right? But I'm not going to write them out like this. Again, I'm just going to count them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 10s. So it is 8 times 10 to the 10th power. So I guess the problem with Lauren is, yeah, the 2 times 4 worked out for her, but 10 times 10 is not good because I'm not multiplying a bunch of 10 times 10s. What I'm multiplying is a bunch of 10s. And how many 10s are there? Well, there's 3 of them times 7 more. So there's a total of 8 10s. Now, I have no idea. I haven't even tried this. I have no idea how this calculator handles that problem. So let's run this through this. So if I have 2 times, and I'll just go 10 to the, to the third, and then I'll say leave the exponent times a 4 times 10 to the 8th. Oh, to the 7th. To the 7th. When I do that, okay. Well, that's nice. Can I leave this? No. Huh. So it is 8 times 10 to the 8th. So, all right, let's move on. Question number 19. Oh, I remember this question. The last time I did these problems, I think my answer key was wrong for like 3 years. Let's get rid of this. So this function f of x is kind of interesting because it says regardless of what you put into it, f of x is always going to be the number 16, right? F of x is 16. If I was to make a table of values for this function, I could say, hey, here's x and here's f of x. If x is 10, it would give me 16. If x was 20, 16. If x was 3,000, right, f of x would still be 16. So this function says regardless of what goes in for x, f of x is always 16. Okay, think I understand why. There's no variable on it in the definition for it, right? It's just basically a horizontal line. F of x is always the number 16. So in A, it says, okay, what is f of x minus the value of 2? Well, it doesn't matter what x is, right? F of x is always going to be 16, and 16 minus 2 is always going to be the number 14. The next one says, hey, what is f of twice x? What does that equal? Well, you can look at it, right? If I was to say 10 is going into that function, what does it do if I give it 10? It doubles it, and what really goes into the function is 20. But you can see it doesn't matter what goes into the function. If 5 goes in, or 10 goes in, or 100 goes in, or 200 goes in, every single time it's going to give me back 16. So f of 2x will be 16 because f of x is always 16. That's the one I think I got wrong last time. And then the last one says, what's 3 times f of x plus 2? So what's 3 times f of x plus 2? Well, we know something about f of x. It's very consistent. It only is 16. So what this would be 3 times 16 plus 2. 3 times 16 is, yeah, I'm entering this on a calculator. 3 times 16 is 48. Okay, plus 2 would be 50. So I get that this is 48 plus 2, which is the number 50. So 3 times f of x plus 2 is always going to produce a value of 50. So f of x was a little boring here because it doesn't matter what you give f of x. It's always going to give you back the number 16. So you can see in this problem, right, the output is decreased by 2. On this one, the input's doubled, but that doesn't have any effect on the output. And this one says, hey, once you know the output, triple it, right, 3 times the output, and then add 2 to that. And that's what we got, 50. All right, let's go to question 20. It says, write an equation for the following situation. You do not need to solve it. Laura takes very good care of her vehicles. She owns a blue van and a red truck. Although she bought them both new, she has owned the truck for 17 years longer than she has owned the van. The sum of the ages of the vehicles is 41 years. They're 41 years old. Okay, so she owns a blue van and a red truck. I'm gonna do what's called a let statement. I'm gonna say let V be the age of the van, and I'm gonna say let T be the age of the truck. And it says although she bought them both new, she has owned the truck for 17 years longer than the van. She has owned the truck for 17 years longer than the van. So I can do this, right? She's owned the truck longer. So the age of the van will equal whatever the age of truck is, what age of the truck is, plus 17. So if she owned the truck for nope, I've got this backwards. She has owned the truck for 17 years longer than the van. Yeah, I often do that. And as soon as I read it and think about it, so this is what I should be writing. The age of the van is whatever the age of, nope, I'm writing it wrong twice. The truck is the older one. The age of the truck is whatever the age of the van is plus 17. So if she's owned the van for 1 year, she would have owned the truck for 17 or 18 years. If she owned the van for 3 years, she would have owned the truck for 20 years, right? Let me read that again. She has owned the truck for 17 years longer than she has owned the van. So the van If the age of the van is V, the age of the truck would be 17 more than that. Okay. And then the other thing it says is that the sum of the ages of the vehicles is 41 years. Okay. So if I take the age of the van plus the age of the truck, I get that the car's ages together is 41 years. So that is a system of equations. We dealt with those last year a bit, and for right now, we're just going to leave these here. There's another way you can set this up, I think using just one variable. I think that's what we would have done last year, but I'm going to leave it here with two variables and my let statement. All right, let's move on to question 21. 21 says plot some points and make a triangle. Okay, let's get a piece of graph paper. Okay, not only did I get the graph paper, but I went ahead and pre-graphed this. So let's look at these 3 points, and they're right here. We've got A is at 2, 2. Yeah. B is at -2, -2. And C is at 8, -2. And then it says, use the function xy, okay, is going to go to the opposite of x, comma, the opposite of y to transform it. Graph and connect the new points and then label this triangle A prime, B prime, C prime. Okay, so let's do that. So I guess I'm just kind of sketching this. Let me sketch these lines for the original triangle. Gotcha. And gotcha. And the rule says it's doing this, right? Whatever the xy is, it's going to go to, if it's going to become the opposite sign. So it says -1 times x, and I can just write the opposite of x, and then -1 times y. So negative y. So if I look at this first point, B, right? B was at -2, -2. If I take -2, multiply that by -1, it becomes +2. So check this out. B is going to end up over here. This is going to become B. This is going to become B prime. Yeah, it is. And then look at A. A is at 2, 2. And if I multiply those two coordinates, +2 by -1 and +2 by -1, A prime is going to end up over here. So this is crazy. A and B are flipping spots. So this is going to be now A prime. The last point that I have is this C, and C is at 8, -2. And according to this rule, it's going to go to -8, +2. -8, +2. So this, okay, wow, that's going to become C prime. So C prime is going to be here. And if I was to sketch this new triangle, what's crazy about this new triangle is it looks like it made a it made a parallelogram with the other one, and I think I suspect I know why. If I was to take the original shape in red, and if I was to rotate it around the origin, I think 180 degrees. Yeah, if I rotate this whole thing 180 degrees, and I guess it doesn't matter if I go clockwise or counterclockwise, I would get that new triangle. So it's a 180 degrees rotation around the origin, and that's what I get. So what did it ask me to say about it? It says, what if anything about the original triangle has been preserved in this image? Oh, everything, right? I mean, I know that this angle right here, angle C and angle C prime, are congruent to each other. This angle right here was the angle, this was originally the angle B, right? And up here, this is the angle B prime, and those angles are congruent. And then this angle A, I'll do 3 tick marks, 1, 2, 3. This went to this one right here. So, and then all the lengths stayed the same, right? This length right here didn't change. It literally lined up in the same spot. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 long. And guess what? This is 10 long. I guess I'd need the Pythagorean theorem to figure out how long these are. But I know because this is, what, 4 by 1, 2, 3, 4, 5. Oh no, 1, 2, 3, 4, 5, 6. 4 by 6. This is by 6. 4 by 6. Because that's 4 by 6 and this is also 4 by 6. They're going to be the same number if I use the Pythagorean theorem to figure out it. So everything was preserved. All right, then the next thing. Now, use a new function. Ooh. I think I'm going to run out of room in my graph paper. So, on this one, because it says the rule now is you're going to take x, y, and instead of just multiplying by a -1, we're going to multiply by -2. So it's going to become this, comma, -2y. So if I start looking at that, this is hard to look at now. I guess you could rewind if you wanted to look at this. Let me erase this and go just think about the new one. So if I think about this now, oh my goodness. Not only are the coordinates going to move, but they're going to become twice the size they were, right? I think I've got some scale factor going on. This is actually going to be like a dilation. It's going to make this larger than the original. So before b was at -2, -2. Well, when I do this, b is now going to go to +4, +4. So this is going to be where my new b is. This is going to be, I guess I'll use a blue pen. This is going to be b double prime. And a, right, a was at 2, 2, and this rule says it's going to go to -4, -4. So this is now the location of a. So it's going to be a double prime. And then c is going to be a problem for me because it's going to have to go to -16, 4. So I know that the line, I mean, if I was going to sketch this, part of the triangle is this side, clearly, right? Part of it is this line, but this has to go all the way out to 16. And then this other one has to go this way too, but they have to go hit that 16. So here's the thing about this new triangle. I believe the angles are the same, right? I believe that this angle is going to be the same following this rotation because there's nothing to make me believe that those angles were distorted. And I could probably convince myself of that in a more mathematical way. I'm just saying intuitively. And I also think the same is true for this angle, right? This angle was A. And when this thing is rotated 190 degrees around the origin, it comes over to here. And these angles, I believe, are preserved. But the side lengths were not. The side lengths I can see from the two sides I do see, or from side what is it, AB, it looks like it doubled in size, right? So it was not preserved. So I would say this, the angles were preserved, but not the size, right? And it has not undergone a rigid transformation, right? This is not a rigid transformation because the size of the shape doubled, right? I get the length of the dimensions doubled. Right, last question says, rewrite each of the following products as a sum using the distributive property. Okay, that's easy. No area model needed here. 5x times another x is 5x squared. This pen looks a little, that's better. Like the red is just too thin. 5x times x is going to be 5x squared, and 5x times -6 would be -30x. -9y times +6, 6 times 9 is 54. This is -54y. And then -9y times -3y should be positive. 9 times 3 is 27y to the second power. So it looks like we are done with this assignment, and we're on to the next thing. This is Ms. Roberts. Talk to you later.